All right. Well, it does look like we are getting people streaming in now from the course. So let's get this show on the road. All right. So it's been about 2 weeks since we did the pull request summary here. Since last week we discussed the excellent paper that Josh found for us. Let's see. There's actually not a whole lot. Um, the only new PR I saw in the last 2 weeks was actually for me. This was just an updated implementation of the cache age binning for the priority cache. Uh, I had thought that it was all in very good working condition, but it turns out that during a run through Tethology that there were sig faults. So I need to go back and take a look specifically at the changes to the LRU cache implementation for the RuxDB block cache. Something I changed for the age binning there apparently is slightly broken. I'll be looking at that at some point coming up. Um, I saw two closed PRs in the last 2 weeks. One was for Prometheus Manager module. Uh, I thought that something like this already merged, but apparently this is new. Offered the ability to disable the cache. Kifu merged that after testing. So anyway, that's there. And then the only other close one was the old version of the cache binning that I had submitted probably a year or two ago. I finally closed that in favor of this new updated rebased version of the same code. There were a couple of updated PRs. Let's see. Neha reviewed the manager TTL cache implementation. There's some additional ongoing discussion and updates, I think, based on her feedback. Um, Igor, it looks like there's a little bit more review on your PG removal optimization PR. Um, I think that previously had been failing tests. Are there any new updates there?
Actually, no, I'm still planning to work on that. So,
Sure, no worries. All right, what else? Async Messenger. There's an optimization regarding header decoding, I guess. Iliad reviewed that, and there was some additional discussion and updates, I believe, but I'm not totally sure what the status of that is beyond that. And then this big one for subtree map removal from the journal. Um, I'm very excited about this, but it's a big, complicated PR, and there was some additional review and update and rebasing of that PR, but I think it's so big and complicated that that the MDS team or the CFFS team would like to see some design documents and discussion about exactly how this thing is implemented. And I know in the past when I've talked to Patrick, he's mentioned that he may want to try to break this up into smaller pieces, just because it is so big and complicated. So we'll see what happens with this, but I'm still very excited about it. Um, no movement, lots of things here. Sage reiterated that he'll do a final review on the BlueFS fine grain locking from Adam, um, which is really good since I think Igor, probably you, and maybe after that me are the only other people that can really review this. And I know I very much believe that you are more qualified to do it than I am. But if necessary, we can maybe also try to review this. But Sage agreed to do it first, so that's good. Um, let's see what else. Not a whole lot of other things. This randomly distributing dirfrags to multiple MDSs needs a rebase. I hopefully the SFFS team could take a look at that. Um, I think now that Mark Kogan is back. He's working on this shared object cache PR for me, updating that and probably expanding it to be even more useful. So that's good. I don't really see anything else here that's worth talking about this week. Did I miss anything, folks? Anything there that I didn't see or that'd be worth talking about? All right then. Moving on. I only have two fairly brief discussion topics for this week. One is that with the downstream testing that Red Hat does, there was a discovery that on some of the nodes that were being tested, there was a huge amount of memory that was utilized on the nodes that didn't appear to be freeable, that was showing up in the uh, proc mem per CPU category. Uh, it appears that we may be hitting an upstream bug when creating and destroying many C groups rapidly. We're not 100% sure on this, but that's kind of our best guess right now. So for anyone that's using Ceph in C groups, specifically Ceph in containers, this may be relevant for you. So check out the upstream kernel bug. The guy that's been working on that has been working on many related issues as well in the kernel regarding C groups, specifically to support their usage at Facebook. So definitely, if you're running into issues with containers or C groups and memory usage, especially slow leaks over time that are unexplainable, this may be what you're looking for. So the other thing that I've got is that to try to get the cache age binning into a shape where we can merge it, I've been running through a lot of tests with it. For people in the core group, you've already seen all of this. For other people, the gist of it is that the cache age binning is not as much of a performance win as I was really hoping it would be. It sometimes is a win, but sometimes it's also a little bit of a loss. It seems like the major reason for that is that I was overestimating the importance of caching OMAP data in kind of the general case. It turns out that when we do age binning, we really don't actually even cache OMAP data very much. The only cases where we really do is during like RGW bucket index listing for like RGW workloads. If we ran a pure OMAP test, we probably would significantly more, but that's kind of rare in practice. It looks like bucket index listing is probably the major common use case where we would see a lot of hot O nodes in the cache. And that use case typically is like scanning, right? Is iterating over a bunch of values. So I guess you would assume that read ahead would be far more important than something like storing these in a longer term LRU cache. So that was a little disappointing, but it's been really good, valuable information. One of the things we did see, however, with cache age binning is that we're doing a better job of removing old O nodes. And because we're doing that, we actually see less fragmentation when workloads change between like large sequential reads or writes and like small random reads or writes. The upside here is that it seems like we actually do a better job of not fragmenting memory as significantly, and that lets us have more cache. Doesn't necessarily always turn into a performance gain, and maybe that's because of other bottlenecks. Maybe it's because caching the kind of seldomly used or older O nodes doesn't actually matter that much. But in any event, it appears that we do a better job with memory fragmentation with this enabled, and Adam kind of convinced me that that maybe I was being pessimistic and it's still worth actually merging this. So in any event, there's some graphs there that I've actually got a ton more data beyond what's in that spreadsheet, but that gives you kind of a decent high-level overview of kind of the behavior changes from page binning versus the current master behavior. One thing to add there is that the H binning failed QA due to sig faults when somewhere in the RocksDB LRU cache, probably there's just a bug in the H binning implementation for that particular cache. So I'll just have to go back and figure out what it is. But otherwise, it did actually get through all of my performance tests without issues. So it seems like this is somewhat rare. We'll just have to figure out what it is before we merge it. And that's all I've got, guys. I see something was updated in the chat window. You think it might be more? Yeah, go ahead, Laura.
Yeah, so I was just wondering if maybe I was curious if you're looking at immediate effects and maybe this change will be, age binning, thanks. I said H. I was thinking maybe it would be more of a long-term effect type situation where if we merge it, we'll see more long-term effects or, since you're not seeing it right away, maybe it still might be worth it long-term.
Yeah, that was actually kind of the intention with it is that, rather than a super immediate effect, we would kind of gradually migrate cache over to like OMAP if we needed OMAP more, or ONode if we needed ONode more, or data if we needed data more. And it does that. I mean, it's actually, if you look at like the memory usage graphs, it's actually doing a fairly good job of that. It's just that we're so dominated by performance drops due to ONode cache misses that like you almost always want to give everything to ONode. There are cases where data cache, giving it to data cache is valuable. And that's like the times when this is actually faster are when you have like a mixed read-write workload where hitting a cached read lets you both hit the ONode from cache and the data from cache. Those are like the cases where we're actually faster with cache age binning. But in like the vast majority of other cases, there's either no difference or even like a slight regression due to like a very small percentage of ONodes that we missed that we would have otherwise hit by caching data or caching OMAP. It turns out that ONode is still like the dominating factor in all of this, which is kind of unfortunate and sad. But it is what it is right now. I still think cache age binning is kind of useful because if that changes, if we get to the point where that's no longer the case, then the age binning should really dramatically help. And there are cases where it does help. It's just I like to say what we have like accidentally optimal scenarios right now where we end up like devoting a huge percentage of the cache to ONode, and it seemed to help, so that's what we did, but we never really knew why or if that really was optimal, and it turns out it is.
Yeah, well, it could still help in those cases, and like you said, if that changes in the future, if the design changes in the future, that as long as it's not causing major regressions, I think it makes sense. If it's kind of keeping things relatively the same, things could change and then it could become really optimal.
Yeah. I suspect there are some cases where it will hurt. The ones where it would hurt are like when if you've done like a big dump of data. So like you've done a fill stage, like you're just like pumping stuff full of data, and then you go back later and are doing like little random reads from that data that you just wrote. In master right now, we almost just ignore the data portion of those writes, and we just cache the O nodes. We always are like O nodes are coming first, always. With cache age binning, it will say, hey, there's a bunch of big writes happening, like 4 megabyte writes, and these O nodes are kind of small relative to that. I'm going to cache the data. I'm going to assume kind of in the future that because I'm doing big writes now, I'm probably going to do big reads coming up at some point. And so it will favor data a little heavier in terms of like a byte value than O nodes. But if later you came back and did like little random reads from those, you'd actually want to have the O nodes cached rather than the data. Whereas if you're going to come back and do like big reads from that data, then you'd want to favor data. Those are kind of the cases where the existing behavior versus the age binning behavior differ.
Well, I still kind of hope that if we merge it, that will give us at least some framework to try to improve it. And on situations that we see that could be improved, because now we're testing on some cases, I guess when other people will test, we could actually adapt better to have a better aging tables for different type of caches.
Yeah, I agree, Adam. I think it gives us a saner way of dealing with all of this than what we have now. I like to use the term, but I feel like we're like accidentally good right now. It's just kind of because O nodes are so dominant from a performance perspective, caching them that we happen to be good because we favor them. But if we like merged Igor's PR from a while back that makes it so that the O node data structures are smaller, it might shift things a little even more towards wanting to cache data or wanting to cache OMAP. So like the more, if we ever do that, if we merge that or merge other things like that, where it means favoring O nodes is less important, the cache age binning I think will even kind of start showcasing more benefit automatically in the background. I suppose the counter argument to all of this is that if we start really putting a lot more resources towards Crimson and Seashore, that will work, completely differently. And it's not clear that we want to do something like this with C-Store. I don't know. We might. That would be a much bigger conversation. I suppose the other argument too is that in a world where you're pre-allocating memory for different caches, maybe you never want to change them. Maybe you don't want to be doing this kind of dance of trying to keep memory under a certain boundary and reallocating memory for different caches and moving things around and evicting here and gaining here. Maybe in that kind of a world, you'd rather just have a static allocation of memory for different things, and you always stay under a threshold because you're allocating from pre-allocated pools, and there things are just much more static. I don't know.
That's correct if you actually know the profile of workload you will have. Then you can actually guess and find the best split. But I don't think it's so for Ceph, at least not for Classic.
Yeah, agreed. But maybe in Crimson we can do that. Maybe we can pre-allocate memory up front, or even pre-allocate it in big chunks, and then, like Laura was saying, maybe you very slowly change that and tweak that, but always doing small allocations from much bigger allocated chunks that happen rarely.
Yeah, that would be interesting to see how that would work out.
I think it's probably a better design than all of this, goofiness that we've done to try to shore up our existing behavior in Classic, right? The memory auto tuning and the cache balancing and the age binning and all of this stuff is really just trying to work around the fact that we make a ton of small allocations constantly.
Yeah, it sort of seems like we do this because this existing thing happens, and this existing thing is because of this other thing. It's sort of like all these different infrastructure decisions are affecting each other, so that it's a little bit difficult, or we're constantly doing workarounds almost. But I mean, what you said about merging this PR to sort of like, even if it doesn't make a huge change right away, to sort of set the ground for moving into creating a better infrastructure that is more sane. I think that's a good like design move, to sort of consider future design and lay the groundwork for better future design.
Yeah, I think so too. The only thing that kind of gives me pause about it is that it is going through and touching a lot of the cache data structures. I think it's more or less mostly fine, but the fact that we hit a seg fault in testing is a little discouraging. Um, it's I like to think of this as fairly clever the way that this is working, but it's definitely touching a lot of stuff that can introduce bugs. So the downside.
Always that kind of a downside.
Yeah, right. Anytime you're touching old code and trying to make it, do things in a clever way, you risk it.
Yep.
All right. Well,
Yeah,
that's all the stuff. Oh, go ahead.
yeah. In our one of our previous discussions about having multiple pools or just fewer pools, especially with Redis Gateway. So if we would have better hints what to do with the data and how the data would be used, so this could be something that we could leverage then to just educate the changes for cache behavior. So it
Sure.
would be one of the things that we could do, perhaps, if we had something like this.
Yeah. Yeah. I don't know if we have any way. I should look. I don't know if we have any way to track like a piece of data in the cache, what pool it's tied to. But that would be also really interesting from a display perspective, right? Like if you could say that, okay, you've got all this data in these different LRU caches. This is data versus metadata for onodes versus OMAP data. But then if you could also present the user with a view of, well, and here's the breakdown in percentage of what pools this kind of data is tied to. Like this particular pool is getting a lot of cache right now. I mean, that could be kind of interesting from a dashboard perspective.
Yeah, perhaps not only from this side, just monitoring and seeing what is done, but also just if we could have some hint what the data is about. Just is this is it as an upload of a large object? Is it something else? Is it a tiny thing? So I don't know. Just I know that other ecosystem think about just giving down hints from application side, also just to educate. This is a content that needs to be cached because I would read it once again soon, and all this information just wouldn't have any meaning to us because we cannot deal with that or cannot prepare for it if we would just have simply the traditional way, the actual behavior. So it might be another case that we see any application soon that talk this way, but it would be just at least a way just to be prepared for something that could be facilitated this way.
Yeah, yeah. Yeah, I've never really thought about it in terms of like even like user supplied hints for pools, like what's important. But that's kind of interesting. All right, well, yeah, neat stuff. Anything else, guys? Anything to bring up this week before we wrap this up?
Not for me.
All right. Well then, I don't have anything else, so we can wrap this up and get a little bit of our time back.
That's good. I'll see you in the huddle later.
Yes, that's in 25 minutes, right?
Yeah.
Cool. Sounds good. Well then, have a great week, everyone. Talk to you later.
Bye.
Thank you, guys. See you
Bye.
later.
Thanks.
Thanks,
Bye.
Mark.